Okay, so in this video I want to introduce you to the concept of kinematics. Kinematics you may have looked at a little bit in physics, but kinematics is basically looking at motion, but not up and down or like over time. What it is just a motion in a straight line. Okay, now we have time involved, obviously, but we're either looking at something that is moving back and forth laterally or up and down. Okay, and this is going to affect the way we think about velocity, but what we're going to be dealing with here is our displacement function. In kinematics, we look at displacement from a starting point, which we call the origin. And our function is just showing our motion along a path, positive, okay, and this is where we have to think about velocity a little bit differently. Positive direction is movement to the right, or if we're looking at one moving up and down, it would be movement up. Negative is to the left or down, okay? Now the motion graph that you can see here would show an object's location at different times. All right, because we're dealing with something that is one-dimensional, it's possible that you could have, for example, a time of 1 here, time of 2 here, but then a time 3 here and a time 4 here. That indicates that at some point we switched direction, came back, and then we switched direction again and went back the other way. Okay, so we'll look at that more as we move forward, but that's the basic idea. On a horizontal motion graph, then our point is located to the right of the origin if our position is positive. It's located at the origin if our position is 0, and it's located to the left of the origin if our position or displacement is negative. Okay, so over here would be negative position. Now, there's a lot here, so I want to focus in on a couple of things here, looking at velocity and acceleration using derivatives. So let's zoom in a bit here. First of all, I want to start about looking at this concept of initial conditions, initial meaning starting or beginning. We're talking about the position at time 0, the velocity at time 0, and the acceleration at time 0. If you are asked to give the initial positions or initial conditions of a situation, you need to give all 3 of these, okay? Now, the nice thing about this is we've already kind of looked at how to get from one to the other when using the derivative. Instead of having a function on a graph, though, we have this displacement function. We take the derivative to get the velocity, the rate of change, and then we take the derivative again to get the acceleration, okay? Notice the acceleration is the derivative of velocity or the second derivative of the position, okay? Now, one thing we need to distinguish here is the fact that we are dealing with instantaneous velocity or instantaneous acceleration. All right, if we are asked for average velocity, that is simply the displacement over time. Okay, so in other words, if you look here at this position here, what is your, if we're starting at a particular time and ending at this second time, what is your position at the first time, and what's your position or displacement at the second time? Our average velocity will be simply the slope, okay? The slope between these two, if we look at those as 2 different points. The interesting thing with this displacement is I could move back and forth and back and forth and back and forth, but if I end right back on the origin and I started at the origin, my average velocity would actually be 0 because my displacements would be equal. So when I subtracted them, I would get 0. It's similar to the concept of work if you studied that in physics. Now, what we are more interested in calculus is dealing with instantaneous velocity, okay? Now, this ought to look somewhat familiar because that's our derivative function, okay? But we can use all our derivative rules to find the instantaneous velocity at a given time by simply taking the derivative, okay? Now, we know that velocity is a vector quantity, okay? The positive or negative will tell us which direction we are going, and of course the value of that will tell us kind of how fast we are going that direction. And that's why we need to make particular care that we note the difference between velocity and speed, okay? Speed is the absolute value of the velocity. We don't care whether you're going to the right or to the left. We just want to know how fast you're going that way. All right, so that's something to be very careful about as you're working through different applications. Now, acceleration. Acceleration can be a little bit tricky in the application, but the concept really isn't that difficult. Similar to how we found average velocity by simply finding the slope of our starting position over time, average acceleration can be found by getting the starting and ending velocities and finding the slope of those over time. What was your change in velocity over change in time? That's average acceleration. Instantaneous acceleration, however, is found using the derivative. So how do we interpret these things, okay? I like this, and this is a slide that you may want to just keep handy as you're working through various problems. But we mentioned this already, the signs of the displacement function tell us where we are, okay? Are we at the origin? Well, then our displacement is 0. Are we to the right or above the origin? Then our displacement is positive. Are we to the left of the origin? Well, then our displacement is negative. The velocity is telling us which way am I going, okay? If the velocity is 0, then at that moment we happen to be at rest. Anytime we change directions from going to the right to going to the left, there's a moment when we are holding still. Just like when we were finding max and min points, there was a moment when the rate of change was 0. Okay? Same idea here. This is the part that sometimes students struggle with. If the velocity is positive, that does not necessarily mean we're going faster. That just means we are moving to the right or moving up if it's a vertical one. If the velocity is negative, that simply means we are moving to the left or down. Very, very important that you get that in your head now. Okay? So the velocity is telling us which way we're going. If we take the absolute value, it tells us how fast. All right? But then we have acceleration. And I like to think of acceleration as kind of which way am I trying to go? And what I mean by this is it's possible to still be moving to the right, but we're slowing down to the right as we try to turn around. If you've ever run on ice, or if you've ever seen a car drifting, it comes around the curve and they're trying to turn this way, but it slides. And it's slowing down as it slides until finally it catches, and then it can come back the other way. Or you see it in cartoons a lot. One person is chasing another, and they slide around a corner. They're trying to change direction, but they haven't quite changed direction yet. And in that moment when they're slowing down, that's where the acceleration would be changing, going the opposite direction. That's which way am I trying to go? Now here's the thing, we can slow down whether we're going left or right. And this is again where we have to think in terms of velocity different than speed, okay? Now, when we say acceleration is positive, that means our velocity is increasing, and by increasing again, that means we're trying to move to the right. It's getting towards positive, even if it is still negative in its value. It's starting to get more positive. The velocity is decreasing if the acceleration is negative. That means we're trying to get more negative. Okay, and I know this is really hard to wrap our heads around, but hopefully as we do some different applications, it'll help us do that. Okay, so to kind of illustrate this, I've given us two sign diagrams. Now, you guys have already done the thing where you are taking the derivative and getting critical values and forming a sign diagram. So you know how to do this. You also know how to do it with the second derivative. Okay? You would find these points of inflection and do a sign diagram. But at this point, instead of looking at concave up and concave down, we're looking at what is our acceleration doing. Okay? So I want to actually look at this and hopefully we'll be able to tell some things about what's going on in this graph, okay, or in this situation. Let me get our highlighter here, okay. I've put these side by side because I want us to see what's going on as we look at these different ranges. You'll notice in this range here, the time happens to be -2. Now, I know that's not necessarily realistic, but we might have been looking at something and we didn't start timing it until a certain point. So 2 seconds before we started timing it, this is what's going on. Well, let's look at what that actually means. The velocity is negative, but the acceleration is positive. Okay? So this means we're still moving to the left, but notice how the acceleration is opposite the velocity. We are slowing down. Okay? We're slowing down. And notice here the velocity equals 0 at -2. We're going to continue slowing down until we hit -2, and that's where we change direction. Okay? Now, our second range here, between -2 and where the acceleration changes at 0, notice what is happening. Okay? Here, the velocity is positive and the acceleration is also positive. Okay? So at this point, notice we have changed direction. We do it there, we do it there, and we do it there. Okay? You could see those as a change of direction, and you can actually see the points of inflection as kind of when we changed our mind about which direction we wanted to go. All right, so in this case, now we're still wanting to go to the right. Our acceleration is positive, and now we actually are going to the right because the velocity is positive. So notice we're going to the right, but since our mind is in agreement with what we're actually doing, the velocity is the same as the acceleration, we are going to be speeding up. okay? And it's kind of like real life. When your brain is the opposite of what your body's trying to do, it's going to slow you down. When your brain and your body are in agreement, it's going to speed up. You're going to be able to do what you want to do. And speeding spelled with 2 E's. All right, so let's look at another example here, or another region here on our graph. Between 0 and 2. Okay? Now, when our acceleration hits 0, that's a point of inflection. So, we must have changed our mind about what we wanted to do. Now, all of a sudden, we've decided that we want to go to the right. So our acceleration is now negative. But our momentum is still carrying us, so our velocity is still taking us to the right. Okay? So we're moving to the right, but since we're trying to go to the left, this is going to slow us down. We've got to slow down before we can change direction. All right? So I hope you're kind of getting the idea here. This continues. I'm going to run out of colors here eventually. Finally, our bodies catch up with our minds, and at 2, we are actually able to change direction. So, our velocity is now negative, and our acceleration is negative. So now that our body and mind are in agreement, we're going to the left, and we're going to speed up, going in that direction. But, of course, we change our minds again. And now we've decided that we want to try to go to the right. Our acceleration changed to be positive. Okay? So now, while our momentum is still carrying us to the left, because our velocity is still negative, we've changed our mind and we're now trying to go positive. So these are in disagreement, so we are going to slow down. And then finally, we figured it out. We figured out what exactly we want to do. We hit 3.5. We make our final change of direction here. And we just continue speeding up and speeding up as we go past 3.5. Okay, this region here. So finally, our velocity is positive, our acceleration is positive, we're going to the right, and we're going to speed up for the rest of this motion. We're going to speed up going to the right. Okay? So hopefully that'll kind of help us understand what's going on a little better here. Anytime your velocity and acceleration are in agreement, you're going to be speeding up. Anytime they're in disagreement, you're going to be slowing down, regardless of which direction you're actually going. So hopefully this gives us a good idea of how kinematics work, a basic idea of what's going on in the situation. And as we move forward, we'll look at various applications, we'll look at motions and see how we can describe those motions in a variety of situations.